So we're still in section 9.2. This is the B part. So in the A part, we did partial derivatives. Now we're going to do second order partial derivatives. As you hopefully remember, you can take the derivative of a derivative. And as it happens, you can take the partial derivative of a partial derivative. Now we've got a couple more different notations. I'm generally going to use these notations. So f with an xx subscript means we're taking the first derivative with respect to x, and then the second with respect to x. If it's xy, the first derivative is with respect to x, but the second is with respect to y. And similarly, we have fyy and fyx. So there are 4 second-order partial derivatives we can find total. Now, you won't have to do all 4 of them on a test, but let's go ahead and find all 4 of them here so that we can get some practice. So here I have my function negative 4x cubed minus 3x squared y cubed plus 2y squared. Now, just like when we did regular derivatives for partials, we've got to find that first partial first, and then we can find the second order. So let's find the partial at x. So again, x is my variable, y is a constant. So I'm going to get negative 12x squared. That y cubed is a constant, so I'm going to get negative 3xy cubed. That is just a y, so that term's going to disappear. All right, so there's my partial at x. So now let's take another derivative with respect to x. So that's going to give me a negative 24x and then negative 6y cubed. And I did a really messy job of boxing that in. Sorry, that's a 3. Let's also do fxy. So again, the first partial was at x, so I'm looking at this, but now my variable is y. Well, that first term, that's only got an x in it. So the derivative of that first term is just 0, but this term does have a y. So I can take a partial on that term, and I'm going to get negative 18, the x is a constant, and then y squared. So those are my first 2 second order partials. To get the other 2, I have to do the partial at y. So the first term, that's just going to be 0. My second term, again, the y is the variable, so I'm going to get negative 9x squared y squared. And then the last term, I will get plus 4y. All right. Now I'm going to do fyy and then fyx. Again, you can do these in any order. The order doesn't matter. So y is still my variable. So I'm going to get negative 18x squared y plus 4. All right, now let's try fyx. So again, I started by taking the derivative of y, so we're using this to start, but now my variable is x. So let's see, that first one, I'll get negative 18xy squared, and that second term is going to disappear. And I'd like to notice something real quick here. For this particular problem, fxy and fyx, I ended up getting the exact same thing. All right, so there is my first example where I found my first order partials and then all of my second order partials. Let's try that again for a different function. Now I've got 2e to the x minus 8x cubed y squared. So again, let's start with fx. So x is my variable. Remember, the derivative of e to the x is e to the x. That first term does not change. Then I get minus 24x squared y squared. All right, let's find fxx. Once again, the derivative of e to the x is just e to the x, so nothing changes there. X is still my variable, so I'll get negative 48x y squared. See if I can box that a little bit more neatly. There we go. All right, now let's try fxy. So again, I'm starting here, but now my variable is y. Well, that first term, there's no y in that. So that is a constant. It's a fairly messy constant, but it's a constant, so its derivative is 0. So again, y is my variable this time, so I got negative 48 x squared y for that second term. So there is my fxy. All right, I'm halfway done. Now let's find f comma y, the partial at y. Now again, that first term, there's no y in there, so that's just going to disappear immediately. And then I will get negative 16 x squared y. All right, so now let's take another partial derivative with respect to y, so fyy. So here I will get negative 16x squared. And last but not least, let's do fyx. So again, I'm starting here, but now my variable is x. And this time I'm going to get negative 32xy. This time, these two were different. So a lot of the problems we'll see, they will end up being the same. This particular one, I did end up getting something different. So those are my second order partial derivatives. And that is everything in part B of section 9.1.